let's take a look at power of a product. So not to be confused with our other exponent that we previously looked at, product of a power. So first let's differentiate between the two of those. So if we have power of a product, if we take a look right here, we've got the power, the exponent, and the exponent is applied to this product. So my base is actually the product. So it's very important that when you expand that, then please leave the base as 2 times 5 and do not use 10. So because we want to see what the pattern is that occurs with that. So that is power of a product versus our first one here was product of powers. So product meaning that I'm multiplying 2 powers together, or more than 2 is possible as well. So product of powers, I'm multiplying powers versus power of a product, meaning that I have an exponent on a base that is the product. Okay, so take a moment and see if you can work through this one yourself. And the verification for all of these would actually be to simply follow order of operations. So your verification would be to say, hey, order of operations would say, I'm going to multiply 2 times 5 because it's in the parentheses, that equals 10, and 10 cubed is this, and that should give me the same as if I were to expand it and find that simplified expression. So go ahead and hit pause and see if you can fill in that table and consider the patterns to create that general rule. Okay, so when we expanded everything, since most of them, the first 5 examples anyway, were all multiplication, then the parentheses weren't necessary. So when we take a look at that first one, and we've got 2 times 5 times 2 times 5 times 2 times 5, the order doesn't matter, so I could really rearrange that to 2 times 2 times 2 times 5 times 5 times 5, also known as 2 cubed times 5 cubed, which is then 1,000. And so similarly for the next 4 cases, we can expand that all out as all multiplication, switch things around, and then rewrite them using powers, and then evaluate those products. And I understand that lots of those products, those are larger numbers. In some cases, yeah, you might need a calculator, or perhaps if we look at the second one, negative 2 to the 4th, and that's something that you guys should know. That maybe you write it out and you get 16, and 3 to the 4th is 81. So perhaps you need to take a moment and multiply 16 times 81, which you should all be very able to do. If we take a look at that last example, though, 2 plus 7 all cubed. And so in this particular case, if I write it out, it's 2 plus 7 times 2 plus 7 times 2 plus 7. And so there's some addition mixed in with the multiplication, which means that we can't just go and mix that up, because that's not going to be commutative as it is. And so we're left with 2 plus 7 all cubed, or the only simplification we could do is 9 cubed, and that is 729. So take a look, and again, for our general rule, we are trying to figure out how do we move from our expression into our simplified expression. So take a look at that and see if you can fill in the general rule in words and also algebraically. So in this case, we can say that if an exponent is applied to a product, meaning we've got multiplication, so keyword right here, then the exponent, can be applied to each factor of the product. So biggest piece right here is that we are looking at products only, not sums, so no addition, no subtraction. Okay, so that's why we call it power of a product. So x times y all to the a is equal to x to the a times y to the a. So that is obviously, and we've talked about this already, that is different than if I have x, y all to the a, because that a exponent in this case only applies to the y, because that is what is directly below it. It is different than if x, y was both, those variables would be in brackets. Okay, so take a moment and see if you can test your rules. So make up some of your own examples. You can be a little creative and use your calculator to check if you want to see if that actually works, or use what you know about order of operations to check your work. So taking a look at some of the examples I came up with, I thought, okay, well, I'll try it with a decimal, so 0.5 or 5/10 times 2, and that's all cubed. And so using our exponent law, we can apply that exponent 3 to each of those factors. So 5/10 cubed times 2 cubed, and that equals 1. If I was to check and verify using a known method, which is order of operations, 1/2 times 2, is 1, and 1 cubed is, of course, also 1, so that works. If we take a look at subtraction, which it shouldn't work because that's not a product, 8 minus 5 squared times 8 minus 5 squared is not 8 squared minus 5 squared, so if I attempted to apply the rule, we would get 64 minus 25, and that is not what we know order of operations would tell us to do, which is 3 squared, also known as 9. So that's a quick confirmation, and it's very, very easy to check if you're not sure. Let's take a look if we now know about the exponent 0. So if I take 4 times 3 all to the 0, it's impossible to expand that one, but if I apply my exponent law, then we know it's 4 to the 0 times 3 to the 0, or 1 times 1, which is 1. If we check, verify using order of operations, brackets first, so then we've got 4 times 3 is 12 to the 0, also 1. Fantastic.